explore more ideas on designing recursive methods, we are going to have some examples. Writing recursive methods in these examples doesn't mean that this is the best approach compared to iterative methods. The idea is just to show you how to think recursively and design a recursive method, although it can be implemented iteratively. In this example, we want to write a method that is called getNumberOfZeros that returns the number of zeros in the integer if that integer is given as an argument. Before we write the recursive method, we need to know how to get the individual digits inside the number and test them whether they are equal to zeros or ones. To do that iteratively using a loop, in the beginning of the loop we use modulus 10 to read the rightmost digit of the number, and at the end of the loop we divide the number by 10 to get rid of the rightmost digit. So in every iteration we read the rightmost digit, delete the rightmost digit, and the number becomes shorter. So when we are going to stop, we are going to stop whenever the number is equal to 0. Now suppose that the input parameter to the method is called num. Then we need to consider two cases. If num is equal to 0, then the number of zeros in num is equal to 1. And if num is less than 10, that means num consists of only a single digit, then the number of zeros in num is equal to 0. But notice that we have already discussed how we are going to process the number. First, we are going to read the rightmost digit by modulus 10, and then we are going to delete the rightmost digit. So if we keep deleting the rightmost digit, eventually we will reach a single digit, and we will never reach num equal to 0. In this case, why we have to include num equal to 0? We include num equal to 0 when we call the method the first time with the input parameter equal to 0. And if the input parameter is not equal to 0, then the first condition never be true, because we are going to test for single digit before becomes equal to 0. So therefore, we are going to have these two cases. Now, if the rightmost digit is equal to 0, then remove it from the number by dividing by 10, and then call the method recursively on this shorter number plus 1 because the removed digit is equal to 0. So therefore, we say that the number of zeros in num is equal to number of zeros in num divided by 10 plus 1. And this is an example. If num is equal to this number, then where is num modulus 10? Num modulus 10 is the rightmost digit, and the number without the rightmost digit can be obtained by dividing the number over 10. Remember, here we are talking about integer division. So as you see that we are expressing the problem recursively by saying the number of zeros in num is equal to number of zeros in num divided by 10, which is the number without the rightmost digit plus 1. Now if the rightmost digit, which is represented by num modulus 10, is not equal to 0, then we can say that the number of zeros in num is equal to number of zeros in the number without this rightmost digit. And what is the number without the rightmost digit? It is num divided by 10. This gives us a clear expression of the solution of this problem recursively. So to design the recursive algorithm, we can express it as follows. First, we define the header of the method. It returns integer and the name is getNumberOfZeros, and the input parameter is called num as an integer. First, we need to implement the first two cases as stopping conditions or the base cases. If num is equal to 0, then we return 1, and this will happen only when we call the method the first time with the input equal to 0. And if num is less than 10, which is a single digit, then the method will return 0 because a single digit less than 10 is never equal to 0. After that, we need to express the solution recursively. Then we say if the rightmost digit, which is represented by num modulus 10 equal to 0, then we need to call the method recursively by calling the method, but the input parameter should be supplied the number without the rightmost digit. And this return value from the number without the rightmost digit, we add to 1 because the rightmost digit is equal to 0. In the last else, if the rightmost digit, which is represented by num modulus 10, is not equal to 0, then we need to call the method recursively by supplying the number without the rightmost digit, and since the rightmost digit was not equal to 0, so we should not add any number to the return value from this method. And this expresses the problem recursively, including all these cases.